right, today we are going to talk about solving systems using substitution. So as a reminder, in algebra, substitution means that we are going to replace a variable with a given amount. And remember that word variable, just a fancy term for letter. So we're going to be asked to find the solution to a system of equations. So every time that we're writing a solution, we are going to write it as a coordinate point, and inside the coordinate point, you're going to have an x and a y value. So what this means is we need to know what does x equal and what does y equal, and we need those to be just numbers, no other variables. Okay, so our first one here, we're going to find the solution. 4x plus 8y equals 20, and y equals 2. So right now, we already know half of our answer. So we know that our y value of our answer is 2. So we're going to use that to help us find our x. So in our first problem, we have x and y, but we can replace the y with this 2. So I would have 4x plus 8 times 2 equals 20. So now if you look, we only have the letter x, which is good because that's what we need in our answer. So I'm going to go ahead, I'm going to simplify that 8 times 2, which is 16. Now I have a two-step equation that I'm going to go ahead and solve. So I'm going to keep that 4x. I'm going to go ahead and get rid of that plus 16. So I'm going to do the opposite, subtract 16. So 4x would equal 4. I'm going to divide by 4. X would equal 1. Okay, so my final answer needs to be as a coordinate point. My x value is 1. My y value is 2. So my final answer is 1, 2. Question number 2 here. X equals 5. 2x plus y equals 10. So in our answer, we already know what our x value is. We know that our x is 5. We're going to use that to help us find y. So I'm going to replace this x with this 5. So 2 times 5, I could use the parentheses like I did on the last one, plus y equals 10. I'm going to go ahead and simplify. 2 times 5 is 10. 10 plus y equals 10. I'm going to keep the y where it's at, so I'm going to get rid of 10 by subtracting it. So y would equal 0. And 0 is a number, so that can be part of our solution. So for our final answer, we want a value for x, a value for y. Well, we have a 5 and a 0. So our answer would be 5, 0. Here I have 2 for you to try on your own. So go ahead, pause this video now and see if you can solve those. On the first one, I gave you a value for x, and on the second one, I gave you a value for y. Remember, we're going to write our answer as a coordinate, x value, y value. Go ahead, pause, and see if you can work these out on your own. All right, so we're going to replace x with 1 here. So 3 times 1 minus 4y equals 19. That 3 times 1 simplifies to 3. So I would have 3 minus 4y equals 19. I'm going to keep that negative 4y where it's at, and I'm going to get rid of that 3. So I'm going to subtract 3. Negative 4y would equal 16. This is a multiply, so I'm going to divide by negative 4. Remember, that's a negative 4. So y would equal negative 4. So in my final answer, I need a number for x and a number for y, so I'd have 1, negative 4. Question number 4 here, I gave you the y, that's 3. So I'm going to replace the y in my problem. 6x minus 2 times 3 equals 18. I'm going to simplify that multiply. So 2 times 3 is 6. Now I can go ahead and solve this for x. So I'm going to get rid of that minus 6 by adding 6. 6x would equal 24. I'm going to divide by 6. x would equal 4. So for my final answer, I have a 4 and a 3. Make sure that you're putting them in order x, then y. So it'd be the 0.43 would be my solution. So to have a solution to a system, we must have the x and y value. So looking at this problem, I don't have an x and y value. I have a multiply in there. So this is going to create an additional step. So what's going to happen is we're still going to replace the y. Notice how this is solved for y. So we're going to replace the y, but now instead of a single value, it's 2 times x. So when I do that, I would have 3x plus my y is 2x, and that has to equal 5. Well, now when I look at that left side, I have 2 x's, so I'm going to put those together. So if I have 3x and I add 2x, it would become 5x. So 5x equals 5. I'm going to divide by 5. X would equal 1. So that's good. We were able to find our value for x. Now we need to find our value for y. Well, in my problem, it told me that my y value was 2 times x. And we just determined that our x value was 1. So y is 2 times 1, which makes y 2. So now I have my value for x and my value for y, so I can put my answer together as 1, 2. Okay, these are a little bit difficult, so it may take a little bit more practice, but we'll get through them. So if we look at question number 5 here, we have a y equals, so we're going to go ahead and replace the y in the other problem. So I would have x minus 2, y is 3x, equals negative 20. So all I did was took that top equation, and where y was, I replaced it with 3x. So I'm going to go ahead and I'm going to simplify this multiply. So I would get x minus 6x equals negative 20. Well, that's a 1x. So 1x minus 6x makes negative 5x equals negative 20. I'm going to divide by negative 5. X would equal positive 4. So we're partway to our answer. We have our x value. Now we need to find y. Well, in my problem, it told me that y was equal to 3 times x. Well, we found x. That's what we just did. So we're going to use that to find our y. So y would be 3 times 4 because x is 4. So that would make y 12. So now we have our value for x, our value for y, and I can go ahead and put that as the answer for 12. Okay, go ahead and pause this, see if you can do number 6. Here x is by itself, so we're going to replace the x in the original problem. Okay, so go ahead and try that. All right, negative 5, x is 4y, then I have plus y equals 19. Okay, so negative 5 times 4y is negative 20y. That's a 1y, so plus 1y equals 19. Well, negative 20 plus 1 makes negative 19y. I'm going to divide by that negative 19. Y would equal negative 1. So we're halfway there. We know what y is. So now our job is to find x. Well, in my problem, it said x was 4 times y. Well, y we just found to be negative 1. So I'm going to replace y with negative 1. So x would equal 4 times negative 1, which is negative 4. So now I have my x number, my y number. Make sure that you're writing them as x comma y. So I would have negative 4 comma negative 1. All right, let's go ahead and try this one. On this one, I don't have an x equals or y equals. Okay, this makes it difficult to solve by substitution. I could solve one of these. Like I could change 2x plus y equal to 12. And I could try to get that y by itself. So I'm going to subtract 2x. Okay, so I would have y equals negative 2x plus 12. I could replace that in that second problem, but this just becomes more complicated, okay? And so this is much easier. So here, I'm going to have y equal 2. So I'm going to replace the y with the 2. So go ahead, pause this, see if you can replace the y with the 2 and solve down for x. So 2x plus 2 would equal 12. I'm going to subtract 2. 2x would equal 10. I'm going to divide by 2. X would equal 5. So I have a value for x. I have a value for y. So I can go ahead and write my answer, 5, comma 2. Okay, so all systems can be solved in different ways. So we've already talked about graphing. Technically, every single one of these we could have graphed and found the point where they all intersect. Some are easier to graph than others. Some are easier to use substitution than others. And so I want to point out kind of what to use when. So I like to use graphing when both equations are solved for y equals. Okay, that y equals is that slope-intercept form which we worked on last unit. And so we would graph the y-intercept, use the slope, find where they cross, and then we would be done. Substitution is a little more difficult. This involves more of those solving equation skills that we've done. Okay, so I like to use substitution if one, I wouldn't call it a problem, one equation is solved for x equals or y equals. And that would be the one that I would substitute. So if I have an x equals, I'm going to replace the x. If I have a y equals, I'm going to replace the y. Okay, so we'll continue working on maybe this one is better with graphing, maybe this one's better with substitution. I think on your homework I went through and told you which ones to use, so you should be good today. So go ahead, start that homework now, and when you're done, find something to keep yourself busy.